Welcome to the IBM Spectrum Protect version 7.1.7 technical update. We're going to go through what's new in version 7.1.7, which became generally available on September 16th of 2016. These are the items that we'll be going over in this presentation, and I'll spend a little bit of time on each of them. Let's start with cloud storage pools utilizing a hybrid cloud approach. A lot of times we call this disk cache, and what this disk cache does is it improves our backup performance. Because cloud containers are largely dependent on the network connections between the Spectrum Protect server and the cloud container, what we do with our disk cache is that we back up initially to some temporary cache backup space on the Spectrum Protect server, and then as we have availability on the network, we feed that data out to the cloud container. This buffering makes the backup more efficient. We can also, during this buffering process, convert those individual objects into larger containers and then transfer them as containers, and this helps even additionally with performance. In version 7.1.6, we introduced this idea of the hybrid cloud. And in version 7.1.6, we streamed out individual extents to all types of cloud containers that we supported. And in 7.1.7, what's changed is now that we've enhanced our stream out to the cloud to include an entire batch of extents when we're utilizing the S3 protocol. This S3 protocol batch extents will be supported on our CleverSafe S3 and our Amazon S3 cloud implementations. And if you want to look at one of the YouTube videos, I do have a YouTube video out there on this. Here's the supported platforms for the hybrid clouds in general: AIX, Linux, x86-64, Solaris, and Windows. And then for the supported vendors we have for our cloud containers, you'll see that both our CleverSafe and the Amazon S3 both support the large object uploads, whereas the OpenStack Swift, IBM SoftLayer, and V1 Swift will continue to push out individual extents to the cloud. The way that you set up a hybrid cloud is, first of all, you have a cloud storage pool defined with encryption enabled, is what we recommend when it is cloud. And then the piece to add the directory cache is you're going to define a storage pool directory and give it some physical directory names. And these directories have to already exist. They must be read-write accessible to the Spectrum Protect instant user. The directories cannot be used by other containers. And if you choose to have multiple directories, that'll help with the parallelism and improve your I/O if those different directories map out to different physical disks. So after you've defined the storage pool directories, then you're going to activate your policy, create nodes, and do your backups. Some of the other commands that are out there that relate to the hybrid cloud would be your delete storage pool directory if you needed to remove one of these directories, update storage pool directory if you wanted to change the accessibility, for instance, to read-only or destroyed, or query storage pool directory. A couple more things on hybrid clouds is when we write to a hybrid cloud, the data is going to be first stored locally in those directory type containers. And when we store it there, it's already deduplicated. If you're using compression, it'll already be compressed. And if you are using server-side encryption, it'll also already be encrypted. The data is then going to be transferred to the cloud in batches of extents within a container if you have the large object upload supported, or by individual extents for the other types of clouds. And when we do this transfer, you'll actually see a process running called local to cloud transfer. So if you do query process, you'll see that out there. We can have multiple threads processing multiple containers at a single time. And the local data will be deleted from the local directory after it's been transferred up to the cloud. Some of the details on that is when we're looking at this large object move for the S3 protocol, we will start moving those objects when either the container is full or if that data has been sitting out in a container for a while and it doesn't appear that anything else is going to be written to it. We'll then go ahead and move it up to the cloud regardless of its fullness. When we move the container, we do lock that container so there's no more updates against it. And remember, inside of a directory, you can have hundreds of containers residing there. And with containers, Spectrum Protect will create and delete those on its own. You don't have to do anything to manage those containers themselves. The containers can be locked from all the updates. Then we have a transfer manager, which is going to upload the whole container to the cloud. And if it's using parallelism, it'll break those chunks up accordingly to figure out the most efficient upload. Next, that name of the objects can be recorded. And that way, if there's any type of failure, we can clean it up afterwards easily. Once the move is finished, then an ID is stored in the TSM database. If you were to run an audit against that cloud, we would fetch the current ID and compare it with the ID that's stored in the Spectrum Protect database. And if there was a match, then we know that the container is valid and there hasn't been any changes. Versus if there was not a match, then we'll mark that part of the container as damaged. So when we've actually uploaded data to the cloud, we record that in the TSM database. And then we store the offsets and lengths of each of the extent chunks inside of the Spectrum Protect database. And finally, we clean up after ourselves and dispose of any of those existing disk containers and allocate new containers as needed out in that disk cache. When we're transferring the data from the directory cache out to the cloud, if you were to do a query container, this is what you would see out there. Prior to the data being transferred, here we have a container that's existing out in the temp directory space. We can see our free space that's available versus after the transfer is completed, we can see now the container is given an actual ID number and the free space is removed because it has been transferred up to the cloud itself. In the previous slides, I showed you how to define a cloud cache utilizing command lines. Inside of the Operations Center, we do have wizards which will assist you, either if you're adding a completely new cloud container storage pool, or if you just want to update an existing cloud container pool and give it disk cache. If you're adding a completely new cloud container pool, you will be prompted in the wizard to create a disk cache, and this is where you would enter the directories. If you wanted to add a cloud cache to an existing cloud storage pool, you would simply go into Storage, Storage Pool, Details, Directories, and then click on the plus directories. And then in here you could add in a cloud cache for that specific cloud storage pool. If one of those directories has some type of problem, maybe there's a hardware problem, you will have an update inside of the cloud container. If you look at the directories themselves, you will see that some of them will have been marked unavailable, and the status for that cloud container will be marked as critical. For CleverSafe and for Amazon, it is possible to have predefined containers out on the cloud provider. The reason people like predefined containers is that they can then restrict access to the bucket or vault creation APIs. They can allow the users to pre-allocate buckets with special policies, access rules, or such. And you can allow multiple Spectrum Protect servers to use the same bucket. In addition, if you wanted, you could allow for each cloud container to have its own bucket. When you are adding in a cloud container, we now have the ability to specify a bucket name if you've already predefined that bucket. This bucket has to be added in before there's actually data in that container pool. And on CleverSafe, you have no need to enable the Vault Creation API nor default Vault template settings. Now, if you see here, we can have multiple containers sharing one bucket. You can have each container having its own bucket, but one container may not have multiple buckets assigned to it. In version 717, we now support Amazon S3 as a cloud container. When we are connecting to this cloud container, your Spectrum Protect server itself could be either in your own data center and simply using the Amazon Web Services known as AWS S3, or your Spectrum Protect server could reside in the Amazon Elastic Compute Cloud known as Amazon EC2 Web Service. Either way, you're going to be creating a Amazon cloud container to store your data inside of it. The first thing you have to do is configure the Amazon S3 for Spectrum Protect, and this knowledge document gives you some hints and tips on things you need to do. That includes, if you want, you don't have to, but you can predefine a bucket like we talked about on the previous page. Then you'll want to go ahead and create a Amazon 3 cloud container, and you can do this either via the Spectrum Protect command line or via the Operations Center. If you're using the command line, you'll just be doing the defined storage pool. The storage type will be cloud, the cloud type will be S3, and then you'll give it the cloud URL, your Amazon ID, and your password for Amazon. The list of the regions for S3 for the URL is listed here on the web page. Now there are some regions that list multiple addresses, and you can choose either of those that you want. However, the new dual stack addresses are for IPv6, and so we don't support them, and we haven't tested them with version 7.17 Spectrum Protect. If you have pre-allocated a bucket, then this cloud URL must map to that same region where the bucket was created. If you did not pre-allocate the bucket, then the Spectrum Protect will create one for you. Once you've created that bucket, you must continue to access it using that cloud URL. The IP and password that you're utilizing are considered the access key ID and the secret access key, which Amazon provides you. And once again, the bucket name is optional. If you've set one up, we can utilize that. Otherwise, Spectrum Protect will create one for you. When we do this defined storage pool, we don't verify the credentials with Amazon at setup time. So if there is a problem with that, you'll just go in and update that storage pool and give it the new ID or URL or password, whatever you entered in correctly. I do have a YouTube demo out there on utilizing Amazon S3 for a cloud container. Now you can also set up the cloud containers with the Operations Center using its wizard. You would go into Storage, Storage Pools, and then click on the Plus Storage Pool. You can see here you'll be prompted for the cloud type, in which you'd select Amazon S3. You'd enter the username and password that Amazon provided for you. And then you would select a region, and this region will automatically populate the URL. With this Amazon S3 wizard, you will be prompted to add a cloud cache directory. So you'll want to go ahead and enter that. Remember, that's going to help with the performance for uploading the data to the cloud. If you are in need of updating any of your Amazon properties, you would simply go into the storage pool, click on details, go to the properties page, and here, once you unlock this cloud section, you can then update things like usernames or passwords or URLs. The next thing we're going to look at is the ability for directory containers to create a copy of their content out to tape. And this could be used as an alternative to replication if you didn't have an additional Spectrum Protect server you wanted to replicate to, or it could be used in addition to replication and just provide a tape copy for disaster recovery purposes. We will have a new type of storage pool, and this pool is what we're calling a copy container. You might also hear it referred to as a container copy pool, same thing. When we create the copies, we create them as part of our protect storage pool command. Now you may recognize the protect storage pool command as what we use when we're replicating one directory container to another directory container. In this case, we are using it to also create a copy out to tape if you have a copy container set up. Copies are used to repair the directory container only. You do not restore directly from a copy container. In order to do the restores, you need to restore from the directory container. So if your directory container was for some reason damaged, you would first repair it with the tape copy and then restore that out to your Spectrum Protect clients. We do have reclamation for these copy containers, but it is different from our normal tape storage pools. In fact, it runs as a part of our actual protect storage pool command. so we don't have to reread the tapes themselves. Let's look at some details on those. Once again, the protect storage pool command is also utilized when we replicate directory container data out to another Spectrum Protect server. The difference here is that our type will equal local. And so when they see type equals local, we know we're making a copy out to the copy container. After you finish running a protect storage pool out to a copy container, you will want to run a database backup. The reason for this is the protect storage pool protects the data, it makes a copy of the data, but you'll also want a copy of the metadata so that if something does happen to your Spectrum Protect server, you have both the metadata and the actual data out on tape. So once again, the copy containers are only used for repairing the directory containers, and you repair the directory containers using this repair storage pool source location equals local. And this will bring the information back from the tape copies and place it into the directory container. Now we can repair either the entire directory if you had a disaster or a hardware failure, or we can just repair portions of that directory container pool. We do bring back the duplicated extents from the tape and copy them back into the directory container as duplicated extents. Now this is not a self-contained backup like backup sets, so you do have to have your Spectrum Protect database up and running. If you had a complete disaster and lost your Spectrum Protect server, you would first restore your Spectrum Protect database, and then you would rebuild your directory containers by issuing that repair storage pool source location equals local, and finally you restore the data back to your clients from the container pool. Space replication for copy containers is different than space replication for our tape storage pools. Space replication for our copy containers is run as part of our protect storage pool command. Space reclamation is performed as part of the protect storage pool type equals local process. You will not see a reclaim storage pool command running for a copy container. The reclaim process parameter does not apply to copy container pools. Instead, the copy container reclamation is done without ever actually having to read the tape volumes. When we get a tape that meets the reclamation threshold that you've set up, and what that means is that the tape has been written to the end, so it was full, but over time data is expired. And when you have a certain percentage of dead data on the tape, and that once again is in accordance with your reclamation threshold, we then take the valid data and move that to another tape and then reuse the original tape. And so with the copy containers, we determine all the valid chunks remaining on the tape, and then during the next protect storage pool command, we simply copy them off of the container storage pool out to a new tape, and then we free up the old tape. And this is nice because we don't have to mount and reread the original tapes in order to do reclamation. In order to set up a copy container, there's two ways to do this. Once again, you can do it through the command lines, or you can do it through the operations center. I'll show you both ways. And the second piece is you can set this up for a new directory container or an existing directory container. In order to set up copy containers, you first of all do need a predefined library and device class that are pointing to an accessible library for that Spectrum Protect server. We don't support file dev class or VTL libraries. But all of the tape features like compression, encryption, and so forth are supported. So you do specify how many parallel processes you want the copy container to utilize, and this is with the protect process portion of the define command. And this basically relates to the number of drives we're allocating for this process. You don't want to exceed the number of drives available in the library. And you also have to consider that there might be other processes on Spectrum Protect using that library, so that will impact the count of available drives. The more processes that are specified will increase the number of volumes used during an operation, so you might end up with multiple half-filled volumes. The next time we write out, we'll continue writing to those volumes, but you just need to be aware that you might have to have more scratch volumes available. We do recommend that the total number of processes used per pool is 20 drives or less, and that's just a testing verification that we've done with our test team. And the more processes that you use, obviously the more memory is going to be required on the Spectrum Protect server. When you initially set up a copy container and do your first protect process, you may find that a lot of drives are initially needed to copy the existing data out, but then over time you'll need significantly less drives once that initial protect storage pool has completed. When we set up these container copy pools, you can now send a copy to be replicated to another Spectrum Protect server and a copy out to the copy containers. So in all, you can have 2 copies of your directory containers. Multiple directory container pools cannot point to the same copy container pool. So each copy container pool is dedicated to a primary container pool. Okay, and here's the actual commands for creating a new storage pool. That's simply your defined storage pool name and device class name. Your pool type equals copy container. You're going to specify your max scratch, your protect process, and your reclaim percentages. Once you've defined this copy container, you're then going to link it to a directory container pool. If it's a new directory container pool, you'll do the define command. If it's an existing one, this would simply be an update storage pool command. And then when you want to update your schedule or create a schedule to do the copy, you're going to have this protect storage pool, source storage pool name, and then type equals local. This command you'll recognize with type equals REPL server because that's what we use for replication. If you choose to use the Operations Center instead, this first screen here shows the storage pools, and then the click on the plus storage pool. So here we're creating a new directory container, and when you create this new directory container, you're now given the option of a copy as well out to tape. And so if you do choose this copy out to tape, you'll give it a name for that copy container, and then you'll specify the device class to go with that. This will also help you set up the schedule to run the protect storage pool command. It will automatically create a schedule called run container copy. When it does this, it will first of all figure out what time your database backup starts at, and then 8.5 hours earlier, it'll specify the start time for this command, and the runtime will run up until a half an hour prior to your database backup kicking off. You can alter these start and end times if you choose. The important thing is you want your database backup to occur after your protect storage pool runs. By default, with the Operations Center, we will have the number of drives to be used as half the number of drives in that specific device class. We'll set the reclamation threshold to 90%, and we'll set the default max scratch to the highest possible value. If you have an existing directory container that you want to add a copy container to, the bottom screen here is how you would do that. You would go into storage pool. You would select your directory container storage pool and then click on more, add container copy pool, and then it'll give you a screen very similar to the one above here to specify the information about that container copy. This is what a directory container pool with a copy associated with it looks like. And you'll see that the type shows as container and container copy. We have a new option on the header here. If you click just on container copies, that will list just your container copy pools that are defined out in your Spectrum Protect servers. If you drill down into the directory container copy pools, you'll see information about the amount of data that was backed up to that container copy pool. You'll see if the container copy pool schedule ran for that day. And you'll see who that container copy is associated with, which container pool. Now, one thing to note is that the amount of data that'll be sent out to tape is slightly less than resides in the directory itself. And this just has to do with overhead data that we have to keep for the directory container, but we don't need for the tape container. If you look at the volumes associated with the directory container, you'll see their capacity, if they're in the filling status. All of these tapes are in filling status, but if one was in the full status, then we might also see a percent reclaimable if some of the data had expired on that tape. If you go into the Container Copy Properties tab here under Storage, Storage Pool, Details, Properties, you will see here how you can alter the number of max scratch tapes assigned, the number of tape drives to allocate, or the reclamation percentage. Inside of server maintenance, you'll see the schedule that was set up by the operations center that was called Run Container Copy. You'll see when that schedule ran successfully, and you'll see what it does underneath the covers here, the protect storage pool command. You will only have one Run Container Copy schedule for all of the directory containers on a Spectrum Protect server. If you already have a Run Container Copy schedule set up, the next time you add in a directory container, it will utilize that same schedule. Notice here, these two schedules are for two different servers. If your directory container becomes damaged and you need to repair it from the container copy pool out on tape, you can do this repair storage pool, the storage pool name, source location equals local, and then you can choose if you want a preview and await option. Local repair goes out and recovers the damaged extents on your directory container storage pool from your tape copy. So the prerequisite for using this is that the data extents have been backed up to the tape, and that would be with the protect storage pool command, type equals local, and that the data extents have been marked as damaged. And you can check that by doing the query damaged command. Now, depending if those volumes are still in the library on site or if you've checked them out of the library and they have to be pulled back on site, we'll take a few different steps. But basically, if they're online, we'll select the copy container storage pool from the copy list, we'll mount that, and then we'll pull all of the extents off there that need to be repaired back to your directory container. If it was off-site, we would simply send out a request for that tape to be brought back on-site prior to us being able to access it and repair the damaged directory container. Okay, so what I just talked about was our ability now to create a copy of your directory container data out to tape, and to be able to use that copy to repair the directory container if something happens to that directory container. The next big item in version 7.1.7 was tighter LDAP integration. We've had LDAP integration for a while, since version 6.3, but our previous version of LDAP integration required you to have user IDs associated with an LDAP organizational unit specific to TSM. Now in version 7.1.3, users and administrators can authenticate with the same user IDs that they use to log on to the Active Directory server. So this basically simplifies the process of authenticating the IDs by utilizing the Active Directory database, and it allows both your Spectrum Protect nodes or your Spectrum Protect admins to be registered and authenticated using your Active Directory default read-only access. Also, if a password gets updated in the Active Directory, Spectrum Protect knows about that. You won't be prompted for password updates. If the LDAP server does not have an Active Directory database, you can still authenticate Spectrum Protect user IDs by using the LDAP server. We support Microsoft Active Directory, Windows Server 2008 or Windows Server 2012, IBM Security Director Server version 6.3 and 6.4. We do have documentation on the older 6.3 methodology for LDAP, as well as the new 7.1.7 LDAP integration. We talk about the system requirements in this tech note, and if you want to see a YouTube demo of me setting up LDAP integration with version 7.1.7, check out this demo. There's basically 9 steps to doing LDAP integration, and we're going to kind of walk through some of the highlights and things you need to consider when doing this. Before you start, you do have to have Active Directory database installed on an LDAP server, and your backup and archive clients for Spectrum Protect must be at least at version 6.4 or later. Storage agents that'll authenticate node IDs with an LDAP server have to be using a secure connection like transport layer security or a VPN. Let's walk through the basic steps here. First of all, you're going to choose an LDAP server and make sure it's configured for TLS. You will need that LDAP server URL and port, so make sure you take a note of that. Next, you're going to select a user ID that's going to interface with the Spectrum Protect server. And so this user ID that you select can be an existing one, or you could create one like TSM owner or whatever you want to call it. But this ID and password are going to be used when we do the set LDAP user and set LDAP passwords commands inside of Spectrum Protect. And so you have to at least have read permissions. And this is the ID that's going to basically coordinate between Spectrum Protect and the LDAP itself. If the password for this ID changes, you do need to go back into Spectrum Protect and reissue the set LDAP password. This is the only LDAP user that you have to do this for. When we start talking about Spectrum Protect clients and admins, we don't have to worry about setting their password inside of Spectrum Protect. But for this particular user who interfaces between Spectrum Protect and LDAP, we do have to pay attention to the password. Okay, next, the LDAP admin is going to generate a trusted certificate and copy it over to the TSM server instant directory. Now we're over on the Spectrum Protect server itself. You're first of all going to copy in that certificate that the LDAP admin just generated for you. And you can name it whatever you want, but it usually ends in .cer. There is a key database that needs to be on the Spectrum Protect server called cert.kdb. You must add or have added the authority certificate for the LDAP server to the TSM server key database. And to do this, you use the GSK8 CAPICMD_64 commands. And those are well documented in the documentation out on DocWorks for this. Once you've added that authority certificate for the LDAP server, you're then going to go into the Spectrum Protect server's DSM server opt file, and you're going to add an LDAP URL. By default, our port is 389. If you do want to change that, for instance, to 341, then your option file will have LDAP URL, the URL :341. Now you need to stop and restart your Spectrum Protect server so it picks up these changes. Once the server is brought back up again, from the Spectrum Protect admin console, you're going to issue a set LDAP user and then the name of that user that you selected back in step 2. So you enter in that user ID, and then you're going to do set LDAP password and specify the password name that goes with that. When you specify these LDAP users, you can either use the principal name or you can use the SAM account name. And this link here takes you to the detailed instructions that walk you through all the different GSK8 commands and so forth, okay? We've issued the set LDAP user and the set LDAP password. Now, any of the existing or new LDAP users can register as TSM nodes or admins. And they can use, once again, either their SAM account name or their user principal name from inside of LDAP. So for instance, you could either do a register node tjong, which would be my SAM account name, authority equals LDAP, and then user ID equals none. And this user ID equals none is important. We'll talk about that in a minute. Or I could do a register node tjong at whatever.com, auth equals LDAP, user ID equals none. And this would be utilizing the full user principal name from LDAP. These will create nodes. Either it'll be a node called tjong or it'll be a node called tjong at whatever.com. So depending on if you use the SAM account number or the user principal name, the node name will look a little bit different inside of Spectrum Protect. Notice, I did not have to specify the password anymore. Spectrum Protect and LDAP will coordinate on that password. Okay, the reason we specify user ID equals none is that so no client owner admins will be created using the same LDAP user ID as the node. And the reason for this is that when your LDAP password expires, if your node was to go in and update that, the client owner admin might not be able to update it again on the same day because of the default restrictions inside of LDAP. So we decided it's best if we simply say, create a user ID that has a different ID than your node name. You can also create a TSM node even if the ID does not yet exist in LDAP. So if I did a register node for Kevin and Kevin does not yet exist inside of the LDAP server, the Spectrum Protect server will issue this ANR3123W command, which basically says node Kevin was not found. It'll still register the node inside of Spectrum Protect, but you can't use that until I go out to the LDAP and register Kevin. Once that's done, then I can start using that node inside of Spectrum Protect. If the password for the nodes created using authority equals LDAP expire inside of LDAP, the next time the TSM node tries to log on, they will be prompted for a new password. That password will then be sent back to the LDAP server and updated there as well. If you tried to do an update node command inside of Spectrum Protect for a node created with authority equals LDAP, it will fail, and it'll basically say the operation cannot be completed when LDAP mode is set to integrated. If you want all of your Spectrum Protect nodes and admins to register utilizing LDAP, you can set default authentication to LDAP, and that'll force all your new users and admins to register with LDAP. So the same procedure that I went through for registering a node, you can also use for registering a Spectrum Protect admin. So instead of register node, it'd simply be register admin, and then you would specify either the SAM account name or the user principal name. If you do want to continue using the methodology for LDAP integration that Spectrum Protect used previously, starting in version 6.3, inside of your dsmserver.op file, you would simply have to say LDAP URL, LDAP with the LDAP URL, and then you have to specify here the organizational unit and the name for the specific owner that you set up inside of LDAP. And so if the TSM server sees this type of LDAP inside a dsmserver.op file, it will then continue to use the older LDAP integration format. And the final update inside of version 7.1.7 has to do with the Operations Center, and it has to do with the at-risk rings. When you set up Operations Center, you were asked if you wanted to consider warnings and skipped files as an at-risk condition for your clients. We've updated how these warnings are applied. If you want to go in and change anything, you go into the little gear icon and down into settings, and then you can choose to check for applications, virtual machines, and system machines this consider warnings and skip files as at risk. Previously, if you had a TSM client doing a backup and it got a return code 8, that was always considered as at risk, and it would show up in the red column here, that particular client. If you had skipped files during a backup, that client would be considered at risk if you had previously checked this box here. Otherwise, those skipped files would be ignored and that client backup would be a normal green. Now in version 7.1.7, the return code 8 for warnings and the skipped file return code 4 files will be considered at risk if the checkbox is checked. So if during a client backup you had either warnings pop up or skipped files, that client will now show up in the at-risk part of the ring if you have previously clicked those considered warnings and skipped files as at risk. If this box was not checked, then the return code 4 and return code 8 are now showing up as a warning inside of the yellow category. This same type of warnings and at-risks will be reflected in the email reports that we sent out on a daily basis. Be sure to check out our blogs if you're looking for more information. We also have some YouTube channels out there that have demonstrations and presentations on various bits and pieces inside of Spectrum Protect. Thank you for your time.